Hello viewers, in this last lecture on internetworking, we shall consider various application layer protocols of the TCP/IP protocol suite. These protocols are DNS, domain name system, telnet, FTP, STMP, HTTP and SNMP. We shall consider these protocols one after the other, and we shall see how these protocols are used to support different applications. First, let us consider the DNS, the domain name system. As you know, in TCP/IP, the IP, the address that is being used is a 32-bit address. 32-bit number is used as IP address. This is very convenient for incorporating this address in the IP header. You can incorporate the source address, destination address while sending the that IP datagram. But for human being, this is very inconvenient. Human being wants some meaningful high-level name attached to their hosts so that they can remember easily and they can communicate conveniently. So a concept known as domain name system was invented, which allows you high-level meaningful names. We shall see how high-level meaningful names can be assigned. In the early years of internet, the names were assigned by the central agency, and that was some kind of flat addressing. In flat addressing, what happens? The name does not change if you take the system from one place to another. For example, in case of your Ethernet, in Ethernet, the address that is being used is 48-bit address, and it uses flat addressing. And if you take a Ethernet card from say India to US, the Ethernet address does not change. On the other hand, the flat addressing has a number of disadvantages. From the name, you cannot make out where it belongs, you cannot do the routing, and there are various other problems. That's why this flat addressing is not popular. And another problem was the number of people, that the number of computers in the network, as it increased, it was very difficult for the central agency like NIC to provide names. The situation was somewhat similar to Kavi Guru Rabindranath Tagore. When he was alive, every person requested him to give the names of a theater, a cinema hall, their newborn child, and so on. And Tagore was overwhelmed. So this type of thing cannot really continue for a long time, and subsequently a technique which uses hierarchical addressing was invented, and that is essentially the domain name system that we shall discuss in this lecture first. In domain name system, the entire internet work is divided into a number of domains. For example, com, edu, government, org, organization, net, AU, IN, JP, US. These are various domains. And these domains are having some subdomains under them. For example, UCF, and you can have some more subdomains under it. For example, IN has a subdomain ERNet, and it has a number of subdomains under it. So in this way, it can have under the domain, main domains, you can have several subdomains. Each of them can have several subdomains, and each subdomain can have several sub-subdomain, and so on. It can continue in this manner. So in this case, we find that a hierarchical structure is being used. you can say this is your root domain, and under this root domain you have got these domains, and these domain names has got two different flavors. One is generic. In this generic, under this generic category, it is based on the use of the, or rather category of the different systems. For example, COM stands for commercial organizations, EDU stands for educational organizations, government stands for government organization, and ORG stands for professional organizations like IEEE, and so on. NET, the network service providers. On the other hand, there are another kinds of domains which are based on country. So here, these names, AU stands for Australia, IN stands for India, JP stands for Japan, US stands for US. So these are the various domains under the country domain. And here you have got based on different generic names based on the use or application of the different organization. Now it provides a very convenient way of giving names to a large number of systems. For example, earlier we have seen that authority for giving name was only with the Network Information Center, or NIC, which is a central agency, and obviously as the number of hosts increases, as the number of systems increases, number of users increases, it is not possible. So here the delegation of authority is given to each of these domains. For example, this edu, under edu it can have a number of subdomains, and the name that can be assigned under edu, that edu server, who is the person who is managing this edu server has the responsibility for giving names under it. Similarly, under UCF, which stands for University of Central Florida, can have a number of domains, and the names under this domain, subdomain, the authority of that is the person who is managing the UCF system. Similarly, look at India. Under India, you can have several subdomains, and one of them is EarNet. And under EarNet, you can have different institutions like IIT Delhi, IIT KGP, IIT Madras, and so on. And in this way, you can have, for example, under CS, it can have a number of systems connected to it, number of users connected to it. Under KGP also, a number of users can be connected to it. And here, for example, I am an user which is under CSE, and CSE is another system. So the name of that system is csc.iitkgp.earnet.in. Similarly, here the name will be cs.ucf.edu. Now suppose if I am an user under this CSE system, I want to send an email to my friend in University of Central Florida working in computer science department. So my address name will be apal@at CSE IIT KGP EarNet.in, and this is the name assigned to me, and I can send it to my friend whose name is Amar at CSE at CS UCF Edu. So you see, this gives a very systematic syntax of names. Using this domain name system, we find that these characters, ASCII characters, are separated by dots, and this gives a hierarchical organization. For example, I know from this name I know that this is in India, and this is under the EarNet, and IIT KGP is under EarNet, and CSE is under IIT KGP, and APAL is a user of the CSE system. So this name helps you can give you the idea where the name belongs, where it is located, and it helps you to routing. Now this domain name system is very efficient. We shall see how the efficiency is increased. And another point is it is very reliable. stored indefinitely, as I because if you keep on storing those information in the management in that authoritative record in the cache, then the size will keep on increasing, but old records are automatically removed based on that time to live, and that's how the caching informs the efficiency. So next time in recent future, if I want to send another email, we don't have, we don't the it will not be necessary to perform this chain. That address mapping can be done by the CSE name server, but this is not an authoritative record, because authoritative records can be stored only in the proper servers, for example CSNAME server, UCFNAME server, or EduSafNAME server. But here temporarily it is stored in the CSE name server, because for example the address can keep on changing, and if it changes here, it will not be changed in the cache memory. That's why it is not permanent, and it is not an authoritative record, but it serves the purpose in the recent time. So this is how the mapping of the address to name is done by in the domain name system. So we have seen how in a hierarchical manner a name syntax is used, and how in an efficient way the authority is given to different domains and subdomains to give names instead of giving responsibility to a central agency, and how it allows the resolution of name to address in a distributed manner by using recursive query. Let us now consider another application, that is your telnet. Uh, Telnet uses a remote terminal protocol. We know that norm in the early years, different terminals were directly attached to the computer. There was a multiplexing card, and that multiplexing cards were having a number of ports to which terminals were connected directly to the system. But now with the help of the internet, it is possible to have a terminal far away from the server. So how that can be done is explained here. That is done with the help of this telnet protocol in the application layer, and it allows you to have a remote terminal. And this telnet is a remote terminal protocol, and it works in that client server uh, mode, as I explained in the beginning. Suppose this is your user IO device, and your server is located at some other place, maybe in some other laboratory, in some other country, or maybe somewhere in this country. So what will be done? The user IO device first uses this telnet client, and obviously it has got some operating system, and that telnet client sets up a link through this TCP/IP internet and connects it to the telnet server, and telnet server has its operating system, and once this connection is set up through this TCP/IP internet, this user IO device functions more or less in the same manner as if it has been directly connected to the system. So after the connection is set up using that telnet protocol, the communication can be done as if this user IO device is directly connected directly to the server system. And this telnet protocol defines a network virtual terminal. As I said, it is a virtual terminal. It is, although it is not directly connected, but it functions at a virtual terminal. And once this connection is set up, the client and server can negotiate options. When a terminal is set up, there are various options, what kind of terminal it is, what kind of speed and various things. Those things can be set up by using by client and server using this telnet, and telnet treats both ends. Both ends means this IO device and the server, the client and the server, symmetrically. Both of them can exchange information and negotiate options for communication between the client and the server. So using this telnet, you can have a remote or virtual things you can do. Uh, Another application protocol that is gradually becoming very popular and widely used nowadays is SMTP. It is Simple Mail Transfer Protocol. Nowadays, for communication purpose, email is commonly used instead of writing letters, and this is being supported by SMTP, Simple Mail Transfer Protocol. And using this, you can send and receive electronic mails. So what is being done? Suppose this is the host, and this is another host here, and these two are connected through a TCP/IP network. So this host A can send a uh, send a email to the to another host, to the destination host, using that well-known port number 25. As we know, in the host you can have different port numbers, and because it is a multi-user system, we have already discussed how well-known ports and different other ports which our users can use have been used. But for email purpose, the well-known port number 25 is allocated, assigned, and that can be used for delivering the email to the host. So this is your TCP/IP internet, and using that internet you can send emails. And uh, what happens whenever the host sets up a connection, a daemon known as which talks SMTP works in this host system, and it accepts the email and stores it in the uh, suitable place in the mailbox. However, if the mail cannot be delivered, then this host will send a error message to the source host through the same path. So it is not one-way communication. The this destination host, if it wants, or destination application, if it wants, it can send a error message that this particular mail cannot be delivered uh, to the destination user or application program, and then it is returned back to the sender, and sender will know after receiving that error message. Obviously the entire message may not be sent, only a small portion beginning of the message can be returned back, and from which the sender will know that message has not been delivered. Now in this case, we have assumed that both hosts, this host A and this host B, both of them are having internet address, and they can communicate with each other directly. This may not be the situation in many cases. So in such a case, some kind of gateways can be used, and with the help of these gateways, the mail transfer can be done. Let us see how this can be done. Suppose this is your host, this is your host A1 or host A, and there is a agent here which is that daemon is working, that electronic, the SMTP daemon is working here, the daemon which talks SMTP is working here, and here you have got a gateway. This gateway acts as some kind of mailbox, and here you have got another host, so host B. So 1, and here you have got 1. So first through the network, this is, both of them are connected to the network. Through the network, this one sets up a link to this, and it can send email, and which is stored in a buffer or mailbox. And this side you have got another network to which this gateway is connected, and you have got another agent 2, and using this, the host B can receive and send emails, and using the process 2. So, using this link, the message can be delivered to this gateway, which acts as some kind of mailbox for a number of users on this side, hosts on this side, and host B, which is one of the users of the mailboxes, can set up a link to this gateway using the SMTP protocol, and then it can receive and send messages using this gateway. So, this is how the email can be sent using gateways, and in this case this host may not be having a IP address. Instead, in spite of that, it can send and receive emails. So, this is how email gateways can be used for sending emails and receiving emails. Now, let us consider another application. In addition to the messages, sometimes a big file has to be sent from one place to another, and that is being done with the help of FTP protocol. FTP stands for File Transfer Protocol, and there is a simpler version of that which is known as trivial file transfer protocol. This FTP allows you to transfer file, performs file transfer and access, and it is also based on the client server paradigm. Let's see how it works. Using FTP, you have got two processes. One is for data transfer, another is for control transfer. So, that is, with the help of this control transfer, you can set up a link. This is your the for the control transfer, this is the client path for the control transfer, and this is the server path for the control transfer. So, using this control transfer process, a link is set up. TCP/IP link is set up. As you know, it is connection oriented link, and link is set up, and after the link is set up, following the usual procedure, data transfer can be done by the data transfer process, and data transfer process can be done by using the conventional ways that and once the link is set up, not only one data, several data can be sent one after the other by this data transfer process, and after all the data transfer has been taken place, then this link can be disconnected, and then transfer cannot be done. So, we find that using FTP, there are two processes, one for linking the two systems, and after the connection is established, the data transfer can be done, and actually many processes, more than one data can be transferred, and after several data transfers, when the data transfer is complete, then the link can be disconnected and for future applications. So, this is how the FTP works. Then, as the network is increasing and it is becoming more and more complex, it is necessary to perform some kind of management so that congestion does not arise, or if some failure occurs, the network knows a particular system, a host or a router or a gateway has failed. That means a central agency or a management system should know how the network is working, or the performance can be evaluated, and for that purpose a protocol has been used which is known as SMTP, SNMP, Simple Network Management Protocol. And this Simple Network Management Protocol provides a systematic way of monitoring and managing network resources. In a big network, in a distributed manner, this SNMP allows you to monitor and manage the system resources. And simple network management protocol has got 4 different functions, and the four components, you can say 4 different components. Number 1 is management station. You can have one or more management stations, and a number of management nodes. The management nodes can be hosts, router, gateways, printers. That means various devices which are on the network, hosts. Different variables. Information can be requested by the management station. As I said, this management station sends a request, and so this is one type of message. Second type of message is get next request. So this message is request the variable following this one. That means in the previous one you have already requested for some variables, and using this message you can request for the next variable. Then you can set request message. With the help of this you can update one or more variables. There are various kinds of network parameters, and those network parameters can be modified, can be changed with the help of this set request message, which can this get bulk request. Using this get bulk request message, the management station can fetch a large table, a large chunk of information can be fetched by the management station from the management nodes. And then information request, this is a between manager to manager message describing local message control blocks. As I said, there can be management information block, base, management information base, and management control blocks can be sent. There can be two managers, there can be more than one managers, and the managers can decide among themselves which parameters each of them will look into, or they can divide their work, or they can check, they can exchange information about local variables. And this using this message blocks, those a pair of managers can exchange information. Finally, this simple network management protocol version 2 trap, with the help of this, the agents in different nodes can send message to a manager to report some trap. So this is using the last one, these hosts, bridges or routers, they can send message to the management station. So we have found that the using this SNMP protocol, using these different messages, a big network can be managed where a particular node or a router or bridge is failed, that can be identified, or if some congestion occurs, then that congestion can be identified. In the early years when this SNMP were not present, then by sending individually to different systems, management was done, but now it is not necessary. Using this simple network management protocol, in a distributed manner, the management can be done using the TCP/IP network. So we have discussed in this lecture this domain name system, Telnet, FTP, STMP, and SNMP. Here we find that this DNS, Telnet, FTP, STMP, all these work above the TCP. That means they use transmission control protocol for communication purpose. That means transmission control protocol, which is a reliable connection oriented protocol, that is being used by these protocols to support their applications. On the other hand, that simple network management protocol uses UDP, which is a connectionless unreliable protocol that we have discussed in the last lecture, and SNMP uses UDP for simplicity because it is within the network. You don't have to go outside the network. That is the reason why it does not use the connection oriented reliable protocol. This connectionless unreliable protocol is sufficient because within a single network the SNMP can be used for management and control of a network. Finally, I cannot complete my lecture without telling something about this HTTP. Nowadays, that World Wide Web, that is being supported by HTTP, which stands for Hypertext Transmission Protocol. With the help of this, not only text, but video and voice can be communicated by using TCP/IP, and that is being supported by this HTTP protocol. So, to summarize the lectures series on this internetworking TCP/IP, we have seen the various protocol under this TCP/IP protocol suite, and we have seen how these internet protocols along with these companion protocols ARP, RARP, ICMP, the communication is done, and then the transport layer protocols TCP and UDP is used, and finally the application layer protocols which are being supported by TCP, UDP and the underlying layers like IP, and finally the network, and that network can be Ethernet, 100 VGNLAN, FDDI, or any of the fast networks, gigabit networks which are emerging. So with this I conclude my lecture on internetworking. Thank you.
4 by n squared to be